Problem 21. We're given the following expression and we're trying to find what that quantity is equal to. So, first of all, you're given, like, circle the z value because the z value has the word I in it, or the letter which represents the root of -1. Anything that has the root of -1 always has a pattern when raised to the power. So, when I looked at the simple formula, which is 1 plus I over root 2, I suspected a very simple pattern, which I got one at z to the 9. So z is equal to z to the 9. So we have a pattern for every 8 terms, right? So given this information, how do we solve the question? Well, I boxed off this quantity because we can first evaluate this quantity, and then we can find this one, because it's just everything reciprocal. So, for the first one, that's z to the 1 plus z to the 4 plus z to the 9. But wait, z to the 9 is a repeat, so that becomes z. Alright, let's continue. Z to the 16, now we have z to the 25. That's too big. So let's first get this down. That's, well, how many 8s are there? There's 24, so there's 3 8s, so that becomes z. Wait a minute. For every odd power, 1 squared, 3 squared, 5 squared, it always goes down to z. Let's make sure, let's get one more term. So 36, and then 7 squared, we get 49. Well, 8 times 8 is 64, 7 times 8 is 56, 4 times 8 is 32, 5 times 8 is 40, 6 times 8 is 48. Wait a minute, so that's 49 minus 48, that's z as well. So 7 squared, 5 squared, 3 squared, 1 squared, every single odd power becomes z. So we have z to the 1 squared, 3 squared, 5 squared, 7 squared, 9 squared, and 11 squared. All of them summed together gives 6 times z to the 1, which gives 6 times 1 plus I over root 2. Now, let's consider the evens. If the odd has a sequence, then the evens must have one as well. 2 squared, 4 squared, 6 squared, 8 squared, 10 squared, and 12 squared. What is this pattern? Well, 2 to the 2, that's just 4. 4 to the 2, that's 16, minus 8, that's just 8. So 36, well, 36 minus 4 times 8 is 32, becomes 4. Wait a minute, so is there an alternating pattern? And of course there is. That's 8, that's 4, that's 8. So there's so many patterns in here, just make sure you're keeping track of everything. So what is z to the 4? Well, I arrowed it. Z to the 4 is just -1. So -1 is z to the 4. So everything z to the 4 is just -1. So -1 minus 1 minus 1. So we got this, this, and this out the way. What about to the 8? Well, the 8th power is just 1. So we have plus 1, that's this one. We have another plus 1, that's for this 8. Oh, sorry. That's for this 8. And then we have plus 1, that's for this 8. -1, there's always a pair. -1 and +1, -1 and +1. So everything becomes 0. So it's 0 plus 6 times 1 plus I over root 2. Now let's consider the reciprocal. Well, the reciprocal, that's just what? That's just everything to the negative power. So if I were to add a negative on everything, then that's the same thing. So what is 0 to the negative whatever power? Well, that's just still 0. So, but what about this quantity right here? What about the negative? Well, that's just 6 times z to the -1, which is just 6 over z to the 1, which is just 6 times, or 6 over, 1 plus I over root 2. So now we have to multiply them together, so this times this. Well, this quantity and this quantity gets canceled out, because they're the same. So that's just 6 times 6, which gives 36, bringing you to answer choice C.